Hello, people of this conference, and welcome to my talk about contextual template states. So my talk is about a very common feature with a very annoying problem, and I want to fix it. So I think most of you already know it, and you have seen it, used, and even implemented it. And I'm talking about different kinds of refreshing states, loading indicators, error messages, completion or success events. And I want to show you different kinds of how we can treat them as developers and how we can use them very efficiently in the template. So basically, whenever we are in the need of implementing such features, we are working with a specific data structure in Angular, and this is the observable. So observables are a reactive data structure which are capable of emitting multiple values over time. But there's more to it. If we take a look at the construction function of an observable, we see we can interact with three different channels. So we have the next channel indicating a new value has passed our stream. We have the complete channel indicating our stream is terminated, no value will ever pass by again. And of course, we have the error channel indicating we have an error. So why is this important? Because from this implementation and from the creation function, we already can derive all the contextual information we need in order to provide feedback for our users. So if we take a look here, we can say, whenever we are doing like our asynchronous stuff before we emit any value, so we are basically in an undefined state yet, we are in suspense state. When our stream has ended and we interact with the complete channel, then we are in a complete or in a success state. And whenever an error was thrown and we interact with the error channel, of course, we are in the error state and have an error context. So if we combine all of those four together, suspense, next, error, and complete, we have a complete, fully fledged set of contextual template states that we can work with. So driven by the observable data source, we can basically derive all the information we need without having the need to work with state management systems in order to make this possible. So how can we actually use this, and what is the actual problem with it I've mentioned in the beginning? Well, with native Angular tools, don't worry, you don't have to read and understand everything that's here, because that's the problem. With native Angular tools, we have to maintain huge amounts of code in both our component and in our template. And I want to show you some ways in order to improve that. And I want to be the problem solver for you in this evening. And let me quickly introduce myself. Hi, I'm Julian. I'm lead performance engineer, trainer, and consultant at the company Pushbase from Michael Latke. You've heard him earlier talking about performance. And more importantly for this talk is that I'm also RX Angular core maintainer. And with the help of RX Angular, with the toolkit we have implemented, I want to improve the horrible code example we have seen before to something that is much more readable, easier to consume, easier to maintain, and has the very same feature set. And you can get a glimpse right here. If you compare it to the horrible code example from before, it's much easier. But I also want to do a little live coding, so I've brought you two demonstrations. One is a nice and easy, simple loading mechanism where we just refresh the page, wait for data to appear, and in the meantime we want to show a loading spinner, nice and easy. And then we will step up the game and implement something more complex that is more like a search implementation where we have to switch between context back and forth. So without further ado, I'd say let's jump into the code and take a look of how it's going. Oh, not the recap, but the demo. Exit this, switch to the code, very nice. But first of all, let's maybe start with the application. So what should we expect? This is our demo application. Do you see everything? Yes. So we basically have a list of movies coming from an HTTP service or a mocked HTTP service, and we can refresh our data and we see nothing. So we want to change that because while we are seeing nothing, we actually want to see a loading spinner. And in case of an error, let's quickly open the DevTools and check this one here as well. We don't see anything, but an error was thrown. So in case of an error, we want to show an error template. So let's dive into the code and start with the template. So this is our starting point. We just have a simple diff with using the ng4. We use our state observable with the async pipe, iterating over movies and creating our movie card. I have predefined templates already for our loading spinner, and I have a predefined template for our error context, so we don't have to care about this later on. Let's take a look quickly at our component. So here we have basically just a creation function that returns us a method from a movie service, basically an array of movies. So how do we get to a more sophisticated implementation with just our native tools? So I'm starting with the async pipe. So that's basically where I'm leading to the horrible code example. So here you can see an implementation with, by using async pipe, we have to move the async pipe one level up, so to the diff of the list, in order to use the ngIf as hack to use our state imperatively in the template. We can also see that we have the need to show an error, so we need to change our state from before. We have to carry the value of the error into our state to use it in the template. So in order to make it possible, we don't only have to touch the template, but we also have to touch the component. So let's fix this as well. And then it should look like this, where we fetch our data, map it to an object where we can read our movies, and in case of an error, we use the catch error pipe and return an error property with true. So that should work for now. Let's double check. Yeah, it looks like it. So if I'm refreshing, I have a loading spinner. And if I'm refreshing with an error, I should end up, yes, seeing an error message. So that's quite nice. But still, there's room for improvement. So let's just implement it in a simpler way. So what I want to show you now is basically the rx-let directive, which we are shipping with the Rx Angular template package. And the rx-let directive, as you can see here, takes directly the observable. We don't need the async pipe anymore. We can derive the state from here directly. And those two inputs are special. So we can give the rx-let directive basically a template which it should display whenever it's in suspense state, and a template whenever it's in the error state. So the let directive is able to derive the observable context on its own without us having the need to change the state of our component. So what I have to do now is basically back refactor what we did before to just the observable, because the let directive will take care of the rest. And let's check it in the actual running application. So yes, again, we see the loading spinner, we see data. If I refresh with an error, the error template should be shown. Very nice. So this is the first improvement, but also a very, very simple use case. So let's step up the game a bit. But first of all, let's do a quick recap of what we have achieved right now. So we have basically used just the observable lifetime in order to determine if we are in suspense, in error state, or in next state, so displaying some values. But of course, we can make it more complicated, display multiple values when it's a stream, a Twitter-like feed, or whatever, and then we can switch to either complete or to error. But we are still limited, because after the complete event hit, the observable is done, it's terminated, so we can't go back. So what if we want to switch between templates in between? There's something missing. For example, if we want to implement a search, we have to show an initial loading state, so initial suspense, then data back to suspense, maybe an error, recover from it, data again. And in order to have this possible, there's a new API which was recently released to the Rx Angular repository, so to the let directive, I guess, and this is context trigger. So context triggers are a way for developers to proactively change the context of the template without having to rely on the observable's lifecycle. So this is just another layer. The actual game changer comes when we combine the context triggers with the observable's lifecycle. So we can add them as another layer on top of the life cycle in order to derive the initial suspense from the observable, also the data. Whenever we want, we switch back to another context, wait for the next value passed by our observable, switch back to the observable's life cycle, and so on. And this will be the basis for our next demo run, so where we implement a search-like functionality. So let's go back again to our code. No, start with the application first as before. So basically we have the same state where we left off. If I refresh, I have a loading state and I have a list of movies, but I have a search input. So I can search here, for example, for Batman movie, and as you can see, it works, but I have to wait 1.5 seconds without noticing that the application is doing something. So I want to show a loading spinner in between. So let's fix that and implement this with our native toolset. So this is the code example we had before with the async pipe. And we want to make it more complex in order to actually show the loading state while we're searching. So let's quickly uncomment it. I've prepared it up front. Okay, so as you can see here now, we just got rid of the loader template which we had in the upper ngIf, and we had to move the loading state inside of our state, so we have to touch the component again, and also we had to move the loading state inside of our template in order to not lose the data while we're searching. Otherwise, we would always like get rid of the list of movies while we are searching, show the loading spinner, and then again, but that's not what we want. So going back to our component, this is what we had before. We mapped to an object of view movies and catch the error and return it. But now, this is not everything we have to do. In order to make it work with the async pipe implementation, now we're at our horrible code example from before. We have to maintain a local cache in order to not get rid of the movies when we switch context and so on and so forth. A lot of code in the template and in the component, but it should work. So let's quickly check. This looks good. If I search, I see the loading spinner and then I see the movie. So this is quite nice functionality, but quite horrible to maintain and quite horrible to code. And let's fix this by using the let directive again. So how can it help us this time? So let's get rid of our async pipe implementation like this and use the let directive instead. You can, from the first side, already tell it's much less code. So here we again have an error template assigned. This one here is new. So RxLet directive is not only capable of using a suspense template or error template, but it has also context variables you can use in the template. So here I'm assigning the S to the suspense context. Whenever this is true, I will show the loader. And for error, I have a completely different template. The difference is, of course, if I would have a suspense template, it would be gone completely whenever all of the rest of the template would be gone and we would show the suspense template instead, but that's not what we want for this demo. Also, this one is new, the suspense trigger. So the suspense trigger is basically a subject in our component. So we can see it here. This is our suspense trigger, just a subject. And whenever this emits a new value, the let directive will switch to the suspense state. Luckily, I don't have to switch code in our template, so I can in our component, so I can refactor it back and can get rid of our horrible state implementation here. And as you can see with the let directive, we can again just use the observable context because that's what it's all about, without having to maintain our own state. And the last puzzle piece is just to trigger the suspense trigger whenever we search. So basically, here I have the method, where is search? Yes, here we have search, and whenever we search, we also trigger our suspense trigger. And with this in place, the functionality should be there again. So if I reset, yes, loading spinner. If I search, loading spinner, and guess I can also search for error. Yes, if I search for error, then I will get an error from the service. So that's quite nice. I just want to show you for completeness to have time left. Yes, 3 minutes left. Nice, I'm on schedule. So now I can show you the full feature set with all of the triggers, because that's quite nice and interesting. So let's go from the simple implementation back here to a slightly more complex one with just a little bit more variables. Yes. Oh, and I've seen I didn't update the variables because we renamed them recently. There's no dollar before. Okay, that should do the trick. So now we have also the complete state here, and we have basically used all kinds of triggers. So you have maybe seen the buttons before in the demo application, and now I can actually use them. So this is my favorite example now. This should work. Yes, I'm searching. Searching is working. And now I have these triggers here, and now I can basically trigger out my context. If I hit error, I'm on error. If I hit next, I'm back at value. If I hit complete, something is completed, back to suspense, to an error, back to next. That's basically it. So there's no recap again. That's everything I wanted to show you today. Thanks for listening. Thanks for having me. It was a pleasure being here. One last thing. Start us on GitHub. Thanks.